Alright guys, today's goal, the learner will understand how to use functions that involve a rational number e. So, e is called the natural number, and it is irrational. It's like pi. Pi is 3.14, blah, blah, blah. Well, this is like 2.712, but your calculator have them to use. But here's the thing, simplify the expression. Treat it just like we learned. When you multiply the same base, what do you do with the exponents? It would be e to the 11th. Here, 24 divided by 4 is 6. 8 minus 5, 3. Here you'd have 10 to the third, e to the negative 12x. But how do I make that positive? So that would be 1,000 e to the 12x. So it's no different than what we've already learned, okay? Now, how do we apply these to other things? All right. A function of the form y equals a e to the x is called a natural base exponential function. So natural base exponential. Those are words you need to know. If a is greater than 0 and r is greater than 0. So both a and the r have to be greater than 0. It's growth. If a is greater than 0 and r is less than 0, it's exponential decay. So a is always greater than 0, but if r is positive, it's growth. If r is negative, decay. So I look at this. It says, graph the function, state the domain and range. So if I just look at this, I know this is exponential decay because in this case, a is 1 because there's no number there, but r is negative 0.75. So that means exponential decay because a is positive, r is negative. Now what does that minus 2 mean? It means it's shifted right 1, or right 2, and then up 1 unit. Okay? So let's just look at this graph. So what they did here, this original graph right here is that one. So they just started by graphing e to the negative 0.75x. Okay? And then see how it's shifted, right 2, up 1, right 2, up 1. That's what that meant. The domain is all real numbers, because they always are. The range, y is greater than 1. It's always going to be y is greater than your k. Okay? Because remember, we still have that k. Alright. So graph the function, state the domain and range. This one you're going to have to be able to use your calculator for. The only one you're going to be able to get is 0. I can start domain. Negative infinity to positive infinity. Okay? So pick these three numbers, negative 2, 0, 2. Those are good numbers for these. So let's just go ahead and use your calculator to graph it. And it's second natural log button for those of you with the TI-83 or 84. Just make sure you're using your calculator correctly here. And then you can look at the table. So for negative 2, I got 4.69. For 0, I got 1.5. And for 2, I got 1.07. So if I look 0, 1.5, -2, and then 1, 2, 3, 4, just above 4.5, and 2, just above 1. So it should look like that. And the range is R is greater than K. Or I'm sorry, the range is Y is greater than K. So, greater than, not equal to. So it's never going to equal that. So it's 1 to infinity because K is 1. Okay? Let's try another. Continuously compounded interest. Okay. So remember when we heard compounded yearly, monthly, weekly? Well, if it says compounded continuously, that's when you use this equation. A equals PERT. So it says you deposit $2,500 into an account that earns 5% annual interest compounded continuously. Find the balance after the following years. So you would say principal is still your initial amount. P is still principal. E, the rate. What's the rate? 0.05 because you convert the decimal, the percent to decimal, times 2. Go ahead and use the calculator. A equals 2,500. E to the 0.05 times 7.5. Okay? Use the calculator to calculate them and we're done. So hopefully we know how to graph these. We're using the calculator and the table function, but we're still accurately graphing. So I'll see you guys tomorrow.